Hello and welcome to my channel. In this video, we're going to be reviewing some general chemistry
Exam questions.
So for the first question here, we're asked to write the formula or name for the following compounds. This one here says iron 3 sulfite. So the first thing is we have iron 3, Fe3 plus. Sulfite is a polyatomic ion that looks like this. It's SO3, 2 negative. Now, according to the rule, you're going to have to swap the charges. So when you swap it, it means that the formula for iron 2 sulfite is going to be Fe, this 2 goes here, then SO3 in parentheses, then you have 3 on this side. So that would be iron 3 sulfite. The next one says copper 2 phosphate. You can pause and try it on your own and then continue the video. Check if you're correct. So copper 2 phosphate will be copper 2. So you have 2 plus. And then phosphate is a polyatomic ion that is PO4 with a 3 negative charge. Now this 2 goes to the PO4. The 3 goes to the copper. So when you write it out, it becomes Cu, then 3, and then PO4 in parentheses, and you have 2. So that would be copper 2 phosphate. Now let's move on to ammonium nitrate. Now ammonium is NH4 with a +1 charge, okay? And nitrate is NO3 with a -1 charge. Now, since both of them are 1, you can just combine them. It's going to be NH4, then NO3. And that would be ammonium nitrate. All right. This one here is dinitrogen pentachloride. The word di means 2, and we usually use these prefixes when you're dealing with a covalent compound. The ones we named over here, these are ionic compounds. But for these ones, this is a non-metal, and we call that covalent or molecular compound. So that's where you use this di. Di means 2, so you have 2 nitrogen, that's what that means. Pentachloride means you have 5 chlorines. So you're going to have this as the formula for that compound. Now, HCl can be named as an acid or as a molecular compound. So we're going to name it as an acid first, and that will be hydrochloric acid. If you are to name this as a molecular compound, it's going to be hydrogen chloride. Okay. Now for this one, calcium, you have calcium, and it has a 2+ charge. It belongs to group 2 of the periodic table. Sulfate is SO4, 2 negative. Now, since both of them are the same, this will cancel out and you just have 1. So they will just combine to give you this. So that is calcium sulfate. Now, pentahydrate, you're going to put a dot. Hydrate is H2O. Penta means 5. So that's going to be calcium sulfate pentahydrate. Now for this one, we're going to name this as an acid, and that is going to be sulfuric acid. Okay. If we're naming it as a molecular compound, it's going to be dihydrogen sulfate. Okay, the next one I have here is magnesium nitride. Magnesium is Mg with a 2+. Nitride is N3 negative. Now combine these two. This goes to this side, the 3 goes here. So you're going to have Mg3, then N2 as your magnesium nitride. SO3, that is a molecular compound. There is no metal, so it's molecular. These are 2 non-metals. So we are going to start with saying sulfur Since you have just one, you don't have to use the prefix for the first element. So sulfur, then 3 oxygen becomes trioxide. Oxygen is oxide. So sulfur trioxide. Chlorine gas would just be Cl2. Now for this one, that would be sulfur, and then you have pentachloride because you have 5 of them. Okay, so that is also molecular. Now the question 2 I have here says to balance the equation below. So we're going to look at my left here. I have 1 of this Fe. Oxygen, you have 2. On the right, I have 2 of this. Then oxygen, I have 3. Now I'm going to start with the F. So I'm going to make this 2. So always you're going to balance the one that is lesser. So I'm going to make this 2. Now this changes to 2, and this is balanced at this point. Now what happens when you have an odd number? There are 2 ways you can balance odd numbers. Put a number here, even though it's fraction, that will make this 3. You need 3 on both sides. If I add 1.5, 1.5 times 2 makes it 3. So that would be balanced. But then you can't leave this equation like that. So you're going to have to multiply the whole thing by 2. And when you do, your balanced equation would then be 2 times 2 here would be 4Fe plus 2 times 1.5 would be 3O2. And then on this side, you have 2 times this would be 2Fe2O3. Note the multiplication does not affect the subscripts. These numbers are not to be multiplied, okay? The only thing you multiply are the numbers in front. When it's empty, it means you have 1. Those are the only thing you multiply. So the one you have below here would then be the balanced equation. Okay, so this would be a balanced equation. So that's one way to go about it. Now, the other way is, let's assume that this is not balanced yet, okay? The oxygen is not balanced. We still have 2 here. What do we do? I would always say, make the odd even. The only way to make this odd even is to add 2 here. That makes it 6. So that means you now have 6 oxygen. Okay, so now it's easy for you to balance this because you have an even number. So you can add 3 in front of that. And that would be balanced for oxygen. But now what happened is that adding 2 in front of this has also affected your ion. So ion is no longer balanced. So you now have 4 on this side. And in order to make this 4, you have to take away the 2 and add 4 here instead. So now you have a balanced equation. So if you do this one, there is no need for you to multiply by 2 anymore. So there are 2 methods. You either use a fraction or make your odd number even, an even number, and that would be easier for you to balance. So that is it for question 2. So for question 3, we were asked to write and balance the chemical equation for the reaction between lead-2 nitrate and sodium iodide. So we're going to start by writing out Pb2 plus. It said lead-2, so that means Pb2 plus. Nitrate is polyatomic, so it's NO3 with a -1 charge. Again, combine these 2 guys. So the 2 goes to the nitrate, this goes here, and the 2 comes here. So what you're going to have would be Pb, then NO3, and 2. Again, I'm not sure if I've mentioned this before. When you have 1, you don't have to write it out, okay? So that's why I skipped the 1. Now we move on to the next, which is sodium iodide. Now the sodium is +1, iodine is -1. So since both of them are 1, you're just going to have to combine it as NaI. So that would be sodium iodide and lead-2 nitrate. Now, when they combine, what do they make? And how can you come about this? Lead has a 2 plus charge. This has a -1. Sodium has a +1. This has a -1. Now, in chemistry, we say that opposite charges attract. So this is going to combine with the negative charge of iodine. And since this is 2, the 2 goes to the iodine, 1 goes to the lead. So you're going to have PbI2. So crisscross, okay? And then the positive charge on sodium would combine with that of the negative of nitrates. And since both of them are 1, 1, you're just going to have NaNO3, sodium nitrate. And that would be the product of this reaction. The next step would then be to balance the equations. To balance the equation, what you're going to do is write out what you have on both sides. So I have 1 lead on my left. Now I'm going to group the NO3 since I have it appearing on both sides. So just group it up. So this is NO3 and you have 2 on the left, Na 1 and sodium 1. On my right, Pb, I have 1, NO3, I have 1. Now, you might be wondering, that is not how it appears, but you want to be able to compare them easily, and putting them side by side is the best. So I always follow the guideline of the first one. Since NO3 is what comes after Pb on the left, I do the same here, okay? So for Na, I have just 1, and for iodine, I have 2. Now, the 2 lead balanced, NO3, when you balance the one that is lesser. Since I have 2 on the left, I want to make the one on the right 2 also. I'm going to add 2 in front of this one. And adding 2 has affected both the sodium and the nitrate. So I have 2 nitrate and I also have 2 sodium. Okay, so nitrate is now balanced. I move on to sodium. Sodium on my left is 1. On the right, I have 2. So I'm going to have to make this 2. Now sodium is 2 and iodine has also been affected. Iodine is also 2. So I have sodium 2, iodine 2, iodine 2, and that will be your balanced equation. For those who are just balancing for the first time, just note that the only numbers you are allowed to change when balancing are the numbers in front of the compound. Okay, you can add, change these numbers in front. Okay, sometimes there is nothing there, so you can add, you can change, but you are not allowed to touch these ones. These ones are subscripts. Okay, they are part of the compound. You are not allowed to touch those ones. You are not allowed to modify or do anything to them. So this will be the balanced equation. Now the next step is to write the ionic and net ionic equation. To do this, you need to know the state of these compounds. And the states, you will be able to figure that out using the solubility rules. One of the first solubility rules is that nitrates, which is NO3 here, are always soluble. They form soluble salts. Okay, so in that case, this is going to be aqueous. Okay, why sodium is also aqueous. So the rule states that all elements in group 1 of the periodic table would always give you a soluble salt. So sodium iodide is soluble. Okay, sodium iodide is soluble. Next, lead. Now, halogens are soluble except for lead, silver, mercury, and some few other ones. So lead is part of that exception. So which means that this is going to be solid. It is not soluble. So it forms a precipitate or a solid, okay, when they mix. Now, sodium nitrate, again, we said that nitrate, sodium, they are all soluble. So this is definitely going to be aqueous. So aqueous means that they can dissolve in water. That's what this is saying. They can dissolve in water. So now we can easily go ahead and write our ionic equation. Why do we need these states? You can only break aqueous solutions into ions. You can't break solid, liquid, and gases. Okay? Only aqueous solutions. That is why you need to know the state The total ionic equation will then be Pb is going to be Pb2 plus aqueous. So their original ions is what you're writing out. Then NO3 has a -1 charge and you're putting aqueous. Remember, if it's 1, you can ignore it. So I'm just going to put negative. And then you have 2 of them. So you're going to have to put 2 here. Okay. Sodium, you have 2 of them also. Sodium plus aqueous. Iodine is 2 also. Iodine negative aqueous. And then on this side, this is solid, so you can't break it into ions. You just have to leave it the way it is. It can be broken into ions. And then this one here will be 2 sodium plus aqueous and 2 NO3 negative aqueous. So this is what we call total ionic equation. Now, to get the net ionic equation, we're going to cancel out the ions that appear on both sides of the equation. So these ions are called spectator ions. Okay, so the first one I can easily see here is the nitrate. You have nitrate on both sides, so that would go. And sodium on both sides, that would also go. Now, at the end of this, there is no more. So your net ionic equation is going to then be Pb2 plus aqueous plus 2 iodide, and this is going to give you Pbi2 solid. So this is what we call the net ionic equation. So the first one is the full equation, while this one is the total ionic equation. The total ionic equation. And then the one down here is what we call the net ionic equation. Okay. All right.